Hello, we're back for sorting methods. This is the third video in the series, and we are going to be looking at quick sort. And as the name suggests, it's very quick. Make sure that you've watched the first two videos, as we will be continuing on with the same project, so you will need those files set up and running correctly before this one will before you'll be able to do this tutorial. Okay, so we've got our previous setup. So we've got our main function, hasn't changed. We've got our bubble sort, we're leaving that alone. We've got our controls, just remember, left creates the array, right sorts the array. At the moment, we've got bubble sort turned on. We're going to turn bubble sort off. So at the moment, there's nothing being sorted. Our array will just come out randomized like when we created it. We also have our insertion sorting algorithm, but we're not going to touch that one either. We're going to create a new file, so we're going to call this one, new tab, quick. And don't be quick about it, but that's what we're going to call it. We're going to name it quick. So, quick sort. Little explanation on quick sort. It's a lot more complicated than the last two sorting algorithms we did. Quick sort uses something called recursion, which is where a function calls itself inside itself. And now that didn't make sense, that's okay. So basically what it says is the function takes in some variables, it does some things to it, but then it calls itself only in certain situations. And it keeps calling itself until it can't call itself because it's got down to a single number. And that is when the program slowly backs its way out. It's like sticking something on a stack and putting another thing on top of it, another thing on top of it, another thing on top of it. You have to take the one off the top first before you can get to the one right at the bottom where you started from. And that's what recursion is. It's basically putting something on a large stack and it's constantly adding to it, and it can't go backwards until it's cleared the thing at the top of the stack. And sometimes the thing at the top of the stack will make the stack get even bigger, and it'll shrink, and it'll get bigger and shrink and bigger and shrink, but eventually it will go back to that first original function, and it'll finish. So we are going to actually have two functions in our quick sort algorithm, and the first one we're going to call quick, and it's not going to return anything. So it's going to be a void function. It's going to be called quick, but it is going to take some inputs because, as I said, quick calls itself again and again and again, and it needs some inputs from the previous versions of itself in order for it to be able to end and finish. So it's going to need int array. So it needs to get the array of numbers that we're trying to sort. It also needs to get the lower and the highest points in that array. So low and high. So when it first calls it, it's going to get 0 because that's always the first element in your array, and the highest element in our array, which is going to be our size, because that's what we've set it up to look like. So it actually takes these inputs and uses them. And we're going to put our squiggly brackets down here to create our function. And as you can see, it's saying we haven't used array yet, and we haven't used low yet, and we haven't used high yet, but we're going to in a minute. So it only calls itself if the low is less than the high. If they're the same, that means it's the same number, or it's not possible for it to actually be the low to be higher than the high in the function. It's just how the algorithm works. But it says if the low is less than high, so it is a number apart, then it'll keep calling itself. All right, so that's where we actually start with. So we actually start with an if statement. We don't actually use any for loops in this because we don't need to recurse inside itself because it calls itself, which is like a loop in itself, which is a little bit hard to explain, but it will become clearer. All right, so we go if lower is greater than higher, and we know that that's going to be true to start with because that's going to be equal to 0. That's going to be equal to whatever our program's set to at the moment, which is 100,000. So between 0 and 100,000, there's a big difference. All right, so what it's going to do is it's going to break our array into two halves. and it's going to then call the quick function again on those two halves, but break the array down so that the low and the high use the halves that it's broken itself into. And we're actually going to use another function called partition, which we're going to have to write as well for this to happen. So we need to get an integer of pi. We're using pi as the index for the partition. So that's the point in the array where it's splitting at. So we got between 0 and 999,999, because that's 100,000 points. Well, that's a million points, so 99,999. That's our two positions, and it's going to put an element in the middle of that, and I'll show you how it's going to do that in a minute. And it's going to break these into two separate quick functions, and this is what we're going to write. So it's going to return that point, and partition is the name of the algorithm it's going to use. And partition actually needs your array, it needs your low, and it needs your high that we got from the beginning. So it got it from up here, your array, that's why it's there, low, low, high, high. Now, of course that doesn't run at the moment because that function doesn't exist. We're going to worry about that in a minute. So we're also just going to write the last little bit of code that we need in quick, which is splitting it into those two components. So it's breaking it down. So you got a whole bunch of numbers on this side, and you got a whole bunch of numbers on this side, and you got this pivot in the middle, which is called pi, just for short, just for fun. Let's call it pi, even though it's not pi. It's not 3.14159263. All right. So we're going to go quick. So that's the name of this function, and we're going to put in the array. So the big array we've got, but our low is still going to be our low end, but our high is going to be where the pivot point is, which is pi minus 1. All right. So we're not actually getting the bang on the pivot. We're getting 1 off the pivot. So we've got a little chunk over here and a little chunk over here, and there's a number in the middle. And that number doesn't change anymore because that's in the middle. Everything else is going to be on the left or right of it. So we've actually figured out one number already, basically just by splitting our code in our array in half. And then we're going to set up the other half. And that's basically how it works. It just keeps splitting it and splitting it and splitting it into two parts and leaving these little dots in between, these little numbers that it's figured out where they should be, until the array splits itself and the low and the high in that array is the same number, and then it goes, oh, well, it's the same number, so I don't have to do anything. It's already in its right position. And that's basically what quicksort is. It's very complicated to think about, but there are videos out there of how it's visualized. You can see the bars moving around. You can have a look at those sort of videos, but we're just looking at the code of how it works. And as I'm talking here, I've just written two separate quick functions, one that breaks into the lower half and one breaks into the upper half, the partitions. We've split it in half. We've left one number in the middle between pi. It is pi because we picked one less than pi and one above pi. So pi is left alone in the middle, pi. We're not going to touch that number anymore. Now, because those quicks go back into themselves, and obviously low, which is 0, and pi, which is going to be halfway. So, you know, like halfway through 100,000 numbers is going to be like 50,000 position. We know it's going to split again, and it's going to find another partition point to split it against, and it's going to do it again and again and again and again until you get down to two numbers, and then it splits those two numbers in half, and well, they're going to be in the right positions, aren't they? All right. So, but what we haven't figured out is how it's actually going to find this midpoint. So let's write the second function, and actually we're going to write it above quick because it has to exist before quick comes along. And in code, reads from top to bottom. All right, so int, and just remember, why are we putting int there instead of void? Because we want it to return an integer. We want it to return this pivot point, and we've written it down here that this function outputs into pi, and pi is an integer, so this function has to return an integer. So that's why we put integer there instead of void. Void doesn't return anything. It's just nothing. It does whatever it needs to do, and it doesn't affect anything else afterwards. Int actually means that we're going to return an integer. You could return a float, you could return a boolean, but in this case we want the pivot point. We want this middle point that it's going to return. So let's write partition. So that's the name of the function we're going to do, just like quick. And what information do we need in partition? Well, we've already told it we need the array, we need a low, and we need a high. So we're going to write that again. We're going to go array, and we're setting up the type for, that's the type, array of what? Whoops, integers, and it's going to be called array. And then we're going to go integer low, because we need the low integer. And don't put 2 commas there, because that's a mistake. And we're going to put in high. Alright. We have a function. Oh, wait, no we don't. Now we have a function. Alright. So it's coming up with all sorts of errors. Why is it coming up with errors? Oh, look at this error. It says this method must return a result of type integer. At the moment, we're not returning anything. There's nothing written in here to say return a number. So it's freaking out on us. That's because we haven't finished writing the code. Alright, so we will be returning an integer, and I'll show you how to do that in a minute. But first off, we need some information. So we're going to start our pivot point at the highest number, at the highest position in our array, which is high, which is our integer high, and we're just going to set it to that to begin with. We're just picking a random number. You could pick the lowest if you wanted to, but we're going to do high for this example. Now there's certain things that will change which way you want to go, and then we're going to actually get the lowest integer, lowest index, so the lowest point in our array, which is this number here, low, and we're going to set that just to I, so we just got it there. We just have that information there is equal to low, but we want the integer just below that, so that actually just gets us a point just below that, and we're just going to put that in brackets there just to make sure it's low minus 1, so it's that position less 1. Alright, now we're going to do a for loop, and we're going to iterate through our array between low and high. So we only want that section of it, because we've got the whole array, we've got all 100,000 or 10,000 or however many numbers we want, but we only want this section of it, the low, between low and high. And that can be a very small section or a very big section. First part's going to be half the array, and it's going to get smaller and smaller and smaller. So we are going to go for loop, and we're going to iterate through. And how do we do that? We go int j. We're going to use j as our random letter, but we're going to start at low. So low not necessarily will be 0, it could be higher than 0. And we're only going to go till j is less than our high point in this chunk, in this partition we've got, this part we've got, this half we've got of the section that we're looking at. And we're going to increment it by 1, which is our plus plus. Alright, so we've got a for loop. Now what we want to do is we want to check j. So we look at our array and we get j's position, and we go if it's less than or equal to the pivot, then we're going to increase I. What that means is I is going to get moved. I is just remember, I is just our low position plus 1. And what we're doing is we're just finding where I should be. And we're moving I up to the halfway point of where it should be. And what we're going to do is I is going to get plus plus, which means added 1 to it. And then we're going to push I, that array piece, down towards j. Alright, so j, where is j at the moment? It's at the lowest point. And we're going to go I and j, they're going to swap spots. So we're just going to push that number up. It's a little bit complicated and confusing to understand why we're doing this. But what it is, it's just meaning that whatever our pivot was, we are just using that as our center point. So if it's less than it, if j is less than it, then I increases. J is not less than it, then I doesn't increase. So we don't have to move towards I. We don't have to move towards our low point. That's it. That's all we're doing. So we need a temp variable because when we're swapping things, we make sure we don't lose any parts of the array I. So we need the number in I, and then we're going to set I to j. So we're going to swap them. I is now equal to array j, and then array j is got to be back. It's got to be what I was, which is here. I was in temp, so j is equal to temp, and we just swapped them over. Right? That's all we've done. Now, so that's going to do that. That's going to push I up in our array till we get to a midpoint. Now, what we need to do from there is swap our pivot. What was our pivot? It was the highest number in our array. So now we actually got to just, all we have to do is just put our pivot point into where I was. Because we were just moving I up into the center, and then we're just grabbing that point, and bang, we're going to put it in the middle of it. So that, what's going to happen? That's going to be our pivot point. Everything's going to split around that number. We were always splitting around our pivot point. Our pivot point is here, and it's the highest number in the array. So it's the highest position in the array. Whatever number that was, everything's being checked against it, because that's what we're doing in... Oop, where have I missed? I missed a bit of code. I've been talking and something's happened. Did I accidentally delete it? Why do I feel like I've accidentally deleted a little bit of code? Let's just go backwards a bit. No? Okay. I didn't delete a little bit of code. Let's just redo control. Let's put all that back in. Alright, so I just missed a whole line of code, was talking about it, and actually forgot to write it. So this is the if statement, this is the pivot that I was talking about, and we never actually wrote in because I forgot to write that in. Okay, that was my mistake. There we go. Oh. Control T, make it look nice and pretty. So, sorry, the pivot, yep, is our number in our highest point in the array, and we're checking J against it. J starts at the lowest point, and it works its way up, and it moves this value of I. This is the index. This is the position, not the actual number of I, but the position of I. And we're just moving that position up, and everything's swapping against the pivot. So eventually I will get to the middle point, and everything on the left of it will be smaller than it. Everything on the right of it will be bigger than this one point, this pivot point we were talking about. Now all we need to do is put that pivot point in the middle. That's all we're doing now. So we are going to, under here, under our for loop. So we've got our for loop, we've got our outside for our function, we've got our for loop, we've got an if statement now, Under here, we are going to swap out I plus 1, so the position just above I, which is the halfway point, with the value of the highest point. So what we're going to write is we're going to do another temp, because we need to temporarily hold our position of array I plus 1. Oop, there we go. And then array I plus 1 get changed into array high, because that was the pivot. That's what our pivot is. That's what this is up here. That's what our pivot is equal to. We could write pivot there instead, but we're just going to write array high. Alright, array high is now going to become temp. So that just moves, that swaps those two around. And now all we need to do is return. And this is what we was talking about right at the start. It returns an integer. And we found out that midpoint, it's I plus 1. That's where array high is. That's where this number that we've been pivoting everything around, that high number where we've been pivoting everything around in here and swapping numbers over and making sure all the ones on the left hand side are smaller and all the ones higher than are higher, so that all the numbers on the right hand side of this pivot are higher. And we actually need to return that pivot point, which is what we use to split our array up. And it's I plus 1. Whatever this position it got to, it's moved them all around. This pivot point, and I's got to this middle section. That's what we want to return back into our quick function. Because remember, it partitions and it returns PI. Then we use PI to split them again into two separate arrays again. This is where this recursion comes in. It's very confusing. You just got to think of that stack. You're just splitting. It's like branching out. Branches it and branches again until all the branches become only one number, and then they're all in order. And this is very fast because as you branch, you're halving the amount of information that you have to look at every time you branch, and it compounds on top of itself until you get down to one number. All right. So we're going to copy paste this quick function, and we're going to go into control. So we've actually finished writing all that information. That was a pretty full-on explanation, pretty tricky to understand. So in between our before and after, we've got our insertion sorting, our bubble sort. Now we're going to have quick. Whoa, it throws up all these errors. So instead of int array in here, what's our array called? Whoops, there we go. Numbers. That's what our array called. What's our low? Now, we haven't actually set that to anything, but we know it's 0 because it always starts at 0. What's our high? That is our size that we've been using in our last program. See how we set size equal to the length? That's what we're using there. The lowest number is always 0. It always starts at 0. So that's all we need to write in here. And this is going to do a whole heap of calling itself and all those things I was talking about, recursion, to get our answer to come out. So if we go to our main function, we've got 10,000. Let's just start at 10,000. I'm not even going to start at 10. All right, let's run it. Bang. There's 10,000 numbers. Bang. Oh no, it's come up with an error. Here we go. All right, first error. Let's see what we did wrong. All right, we're going to have to stop the program using the stop button. Let's have a little look at our... Okay, where do you think it crashed? Where do we think it crashed? Let's look through. We've got our array, we've got our low, we've got our high. Pivot array high. I set to the low -1, which is good. That's what we want. J is equal to low. Yep. J is less than the high. Yep. J plus plus. Okay, we've got our array is less than or equal to our pivot. Perfect. I plus plus. Not seeing any errors just yet. Temp. Yeah, we're swapping them around. That's just a flip. Yeah, we're flipping it there too. I don't think there's an error in there. What about in here? Have we got an error in our high low? Let's have a little look. Let's see if we can figure this out. Going high low there, high low there. Alright. What have I done wrong? Where have I gone wrong? Oh, that's what I've done wrong. So we've inputted high, but when I wrote it into here, into our controls, what did I do? I did size, but that's 10,000. That's not our high. That's not the highest point in. Sorry. What are we starting at? 100,000. That's not our highest point in our array, is it? Highest point in our array is 99,999. So we want size, except we want -1. We've made a mistake. It's alright to make mistakes. You get crashes, you get errors. Alright, so that's how it got over. It got to 1,000. 10,000. It shouldn't have got there. Alright, let's run it again. Click. Alright, we've got our numbers. Bang. Alright, whoa. We've done 100,000 numbers in 17 milliseconds. So that's like 1/100th of a second. Alright, so we've got to pump these numbers up. What if we do 1,000,000? Before, when we did 1,000,000 on bubble sort and insertion sort, it crashed, didn't it? We're going to run it again. We're going to click. Oh, we've got to let it occupy all the numbers. There we go. It's got them all in. Right click. Oh, whoa, it's doing it. It's doing it. It didn't crash. That took half a second. 512 milliseconds. That's half a second. Give or take 12 milliseconds. Wow, that's 1,000,000. So let's see if we can actually push this to the limit. Let's do 10 million numbers. Let's run that. Left click. Let's get the numbers to randomize. Oh, this is taking a while. We're just going to watch it. Look at all these numbers. You can see them just constantly adding and adding and adding numbers. It's going to take a while just to add all the numbers. Oh, wait for it. It'll get done in a minute. Adding all these numbers. So there we go. We've got 10 million numbers now. Now, take a guess. How long do you think it's going to take? 10 million numbers. That's another factor of 10 on what we were just doing. That took half a second. Ooh, give it a try. Let's see. Right click. Wait for it. It's going to take a minute. It's going to take its time. Let's see if it can do it. Oh, it's taking a little bit more time now. Factors of 10 is a pretty big change. See if we can't get it to work. Is the program going to crash? Oh, we might have crashed it with 10 million. Yeah, it looks like we crashed it with 10 million. Oh, wait, whoa. It's done. It's ordering them. Look at that. Still in the 300s, up into the 400s. It's actually doing it. It actually didn't crash. It was just calculating it still. It took a while for it to calculate. Took a while. Whoa, here we go. 45,215 milliseconds. So that was 45 seconds. It took 45 seconds to calculate 10 million numbers and order them from lowest to highest. That's pretty impressive. Alright, that's where we're going to leave this tutorial, and hopefully in the next tutorial we might have a little quick look at shell. Shell is a very, very complicated algorithm, but it works. Alright, I'm going to leave it there. This is the last tutorial for a little while. Shell will come out soon, but not today.